Welcome to this lecture on biomathematics. We have been discussing different things like calculus, vectors and all that are relevant to various biological problems to understand various physical phenomena that might be relevant to biological systems or that are relevant to biological systems. Today, we will go to a different section or different area called statistics. As you all might be aware, statistics has a very important role in biology. So, in the coming few lectures, in the next few lectures, we will try and understand how one can use what is statistics and how one can use statistics in biology, and why do we need statistics and those kind of things we will try and understand. So, today's lecture is statistics, that is the title of today's lecture, and let us think about asking why, as typically we do always. Let us think about asking the question, why do we need statistics? Why should we learn all this at all? Okay, so there are many reasons. We will come, and as the end of this many sections, you will be clear why we need to learn statistics. But biology is a physical science, and the understanding of systems, biological systems, are mainly obtained through experiments. So, we do many experiments to understand the biological systems, and when we do typically experiments, we get a lot of numbers, a lot of data. So, which are like a set of numbers, and how do we make some sense out of these numbers? Like just me a number wouldn't mean anything. So, one way of this idea of to understand some ideas from statistics is absolutely necessary to make some sense out of the data that we are getting, and even to understand like whether the data is correct or like how should we do the experiment so that we get something meaningful. To plan the experiments properly, one need to understand statistics in principle. So, that is the aim. Like we will see what kind of experiments one should plan, so that the data that we get out of these experiments have some significance, statistical significance, or it has some meaning. So, even before doing an experiment, one should think about how to plan this experiment keeping statistics in mind. So, when we use statistics in our daily life, so basically what we are saying is that experiments or simulations produce large amount of data, and how do we make sense out of this numbers that we get large numbers. But before going to experiment, even in real life, we often use statistics, knowingly or unknowingly. So, let us take some simple statements that we make in our daily life, and let us think about what do we mean by that. So, let us see, like one statement we make is this. So, we often say, for example, that it takes 30 minutes to travel from my college to my college from my home. So, that like all of you would have told to somebody that it takes like this many minutes, it takes 30 minutes to reach my college, or it takes 30 minutes to go from here to there. It takes 30 minutes to go to the nearest movie theater. So, you say such kinds of statements you always make in day-to-day life, and what exactly we mean here? Let us think about it. When we say it takes 30 minutes to reach my college, what exactly do we mean here, and what we do not mean? So, look at here. So, what do we mean, and what we do not mean? And surely we do not mean that each and every day we take precisely 30 minutes. This is not true, right? In some days you might take like 40 minutes, like so, let's say one day the traffic is very heavy traffic, like, and the buses are going very slow, then you might take much more than 30 minutes. Some day the roads could be empty and you might reach there in like 20 minutes. Some days you might take 35 minutes, some days you might take 25 minutes. Like even if you are walking, let's say you are walking, you are not going by bus, so the traffic do not influence you. Let's say you are walking, someday you might have some physical, you might not be that fit to walk very fast, so you will walk slowly, so you will take like the 40 minutes. Someday you might be very, you are feeling good and you can walk pretty fast, and then you will be reaching in 20 minutes. So depending on various conditions, it can fluctuate around 30 minutes. And when we say it takes 30 minutes, what we typically means is that on an average it will take 30 minutes. That is what we are meaning. We mean on an average it takes 30 minutes. So that is what is written here. When we say that when we say that it takes 30 minutes, what we are saying is that it will take 30 minutes to reach the college on an average. On an average it will take 30 minutes to reach. So when we say such things, we are using the idea from statistics called average or mean. Knowingly or unknowingly you use this idea called statistics, and you without, even if a layman who has not learned any statistics has this intuitional feeling about average, or even layman, when he would say or she would say that it takes 30 minutes to reach from here to there. When that person says this, she doesn't clearly mean precisely 30 minutes, she surely means that on an average it will take 30 minutes. So this average is like in our day to day activities, when day to day life, this idea of average is actually built in. It's intuitional, it is we have this intuitive feeling that what an average means. But when we are in science, like when we do science, we have to be more precise, especially when we do mathematics, we have to be we have to write things very precise manner. So science is like the more precise you say, it is more reproducible and more scientific in some sense it is. So we like things to be stated in a very precise manner. So when we say average, we have to tell what exactly this average is. So let us take an example. So let us imagine that your act of going to college, from home to college, think of it as an experiment. So traveling to college is an experiment. So you start at a particular time, you look your watch when you start, and when you reach the college you look the watch and note down the time. Let's say every day you note down the time it takes to reach the college. So you have a table. The day 1 it took 35 minutes, day 2 it took like 25 minutes, day 3 it took some other minutes. So you can essentially, you will get a table. So have a look at here, this is some typical example of a table if you wish. So we are thinking traveling to college as an experiment, and each day we are noting down the time it takes to reach the college. And day 1, let's say it took 27 minutes, day 2 it took 33 minutes, day 3 it took 31 minutes, day 4 it took 29 minutes. So none of these days, if you look, we have not taken precisely 30 minutes, like somewhere around 30, some days 27, 33, 31, 29. Still, when we ask, we will say it's like 30 minutes. So what do we mean by that? So that is the definition of average. The average is defined in the following way. So, the average or mean, it is also called mean. So, the mean time to reach the college, so there is a C missing here, it's like college. So, the mean time it takes to reach college can be calculated in the following way. So, let us look at here. So, the mean time, so here we are. So, the mean time to reach the college is 27 plus 33 plus 31 plus 29 divided by 4. So, on an average they take 30 minutes. That is what this average. So, the definition of the average is sum over all this and divided by the number of events. So, number of experiments. So, we have like four experiments here. Day 1 one experiment, day 2 another experiment, day 3 another experiment, day 4 another experiment. Then you can add the data that you get from all the experiments and divide by this. So, you get the average. So, this is minutes, this is minutes, this is minutes, this is minutes. So, and this is a number, so number of days, number of experiments. So, this answer here is actually in minutes. So, this will be minutes. So, we can say that we did found the, so this angular bracket around T means that average. So, I will typically denote average by this angular bracket. Some people denote this by bar. So, some people denote T by average by T bar. So, like T bar is T 1 plus T 2 plus T 3 plus. So, you can take many n experiments and divide by n. So, some people write this as T bar. So, both mean the same T or T bar, T angular bracket or T bar. This is some typical notations for T average, average time, and this is the answer. Okay. So, we can generalize this as T 1 plus T 2 plus T 3 plus dot dot dot, that means T 4, T 5, T 6 up to n if you do n experiment. So, the n was 4 in the previous case. So, it was just T 1 plus T 2 plus T 3 plus T 4 and divided by n. This can be written as in mathematically as using this symbol called sum, sigma. So, this is capital sigma. So, sigma I equal to 1 to n means you do this sum T I will vary from 1, I will vary from 1 to n. So, somebody tells if when you say sum over I is equal to 1 to n T I, this means that first I is equal to 1. So, T 1, then I is equal to 2 T 2. So, sigma means sum. So, this is sum, then sum by putting I equal to 3, then you have to just sum till I is equal to n. So, the sum over I T I sigma I T I means this. So, when somebody says, if you see this symbol sigma, this is what it precisely means. So, mathematically this notation sum over I, this sigma notation, capital sigma, is typically used to represent summation. So, the average T average is nothing but sum over I T I 1 over n. So, this is what it is. Now, let us take another example. You might have also said, for example, my mark is 70%. So, let us take this example. Let us say, we often say that I have got 70% of mark for my class 12 exam. So, this is something that we often say. We often say that I have got 70% of mark for my class 12 exam. What do we mean? We mean that average of all subjects is 70 out of 100. So, if I find average of all subjects, I will get 70 and the total mark is 100. So, 70 by 100 is 70%. So, let us try and understand this a bit more. Such a situation you might have said it. So, let us take one case for this. So, let us case this particular case. So, in this case I am discussing 3 subjects: biology, physics, chemistry, and biology has 75 marks, physics has 65 marks, chemistry 70 marks. So, you got 75 for biology, 65 for physics and 30 for chemistry, and the average is 70. So, even in this case you will say that okay, I got average mark 70 for my class 12 final exam. You are correct. But your friend will come and tell you, I also got average 70% marks. What are the marks he got? She got, like your friend got 95 for biology, 40 for physics, 75 for chemistry, and the average of this 95 plus 40 plus 75 divided by 3 is 70. So, your friend also got average 70% marks, you also got 70% mark. So, what is the difference? Is there a difference? Are they the same? So, if we found the statistical quantity called average and we got the same thing 70, but the marks seem to be very different. So, let us compare these marks and then think about what is the difference. So, biology you have got 75, your friend has got 95. Physics you have got 65 and your friend has got only 40, which is much less than this. On the other hand, the biology your friend has got very high mark. Chemistry you got 70 and you got friend 75. So, by looking at this, what would you say? You say that when your marks are seen, you are pretty much good in everything. You have got 75, 60, so above 60 or close to 70 in everything. So, you are equally good in all subjects roughly, but your friend is very bad in physics and very good in biology. So, biology is like 95 and physics is very 40. So, there is some difference between these two, but the average is same. So, even though the data is different, the average is the same. So, by just telling somebody that I got average 70 marks, that does not mean a lot. It only means that it does not tell you much more information, it hides a lot of information. Just by stating average alone will hide a lot of information, it is not telling you the complete story. Look at this. So, if you look at here, you can, if you tell this full mark, you will see that this gives you the full information, this marks, but just by saying you both got average 70, you are hiding the fact that you are equally good in everything and your friend has some extremes, like very bad in physics and very good in biology. So, this is kind of extreme marks, but we are hiding this fact by just saying that you have average 70. So, now how do we convey this little more information than the average? So, this is true for, so now when we say about mark, the same thing you can think about average experiment. Let us say you are measuring the length of something, or you are measuring the amount of concentration of something. So, the concentration in 10 experiments, in one experiment it could be like, instead of marks you can put like micromolar or nanomolar, and see like all these experiments you could have and say that the average concentration is 70 micromolar. That does not mean that all the experiments had very close to 70, that does not mean. That only means that the sum of all these concentrations you measured in one experiment, in all the experiments, divided by the number of experiments is 70 micromolar. But that does not mean that in one experiment you might have had taken 40 micromolar, in some other experiment you might have taken 95 micromolar. So, whatever we have here in terms of mark as we presented here can be even equally adopted to concentrations. So, instead of this you can say experiment 1 75 micromolar, experiment 2 65 micromolar, experiments 3 70 micromolar, and 95, 40 and 17 some other experiments. So, even here there is some difference in the way you have done experiments, and it is not basically reflecting when we just say average. So, what is the thing you should say? So, the answer is standard. You have to know something about standard idea of standard deviation in statistics. So, when we say about standard deviation, when we state standard deviation, that gives you little more information than just the average. So, when you say standard deviation, there is some deviation. So, what is deviation? Deviation from what? So, the answer is deviation from the average. So, we already got to know about average, and we have to think how much it deviates from the average. So, let us look at here. So, we had 75 marks and the average is 70. So, when we say 75, the deviation, that is the mark minus the average, that is 75 minus 70 is 5. So, the deviation is 5. Here the deviation is minus 5 because mark minus average, 65 minus 70 is minus 5. And here the deviation is 0 because average is same as the mark itself. So, what is the sum of deviations here? 5 plus minus 5 is the sum of the deviations, and the sum of the deviation is 0. Now, look at here. Here the average is 70. So, deviation is mark minus average, that means 95 minus average is 25. 40 minus 30 is minus 30, and 75 minus 70 is plus 5. So, here also the deviation is 25 minus 30 and 5, and the sum of this deviation is 0. So, you find that the sum of the deviation, so when we define deviation as the deviation from the average. So, let us define deviation di as the mark we got in ith subject minus m average. So, or if any variable, if you are measuring some other thing, length or any quantity x, this is can be written as di, this is deviation. So, we can call this deviation, and we found that the sum of the deviation is 0. So, what do we do when the sum of the deviation is 0? So, this average of the deviation is 0. So, sum is 0. So, average deviation or the mean deviation is 0, because mean deviation is 1 over n by 0 is 0. So, something is 0 mean, something average is 0. So, you cannot talk about average deviation because it is meaningless, because it is always 0. Whatever the example you take, you will always find that if you define deviation in this particular way, the average deviation will be 0. You can see that if 5 plus minus 5 is 0, 25 plus minus 30 plus 5 is also 0. So, you find sum as 0, if in any case if the sum is 0, the next thing you do is find the square of the sum. Find the square and then sum. What does that mean? So, we had di is equal to mi minus m average. We had di is equal to mi minus m average, and sum over I di was 0. So, instead of finding sum over I di, I can find sum over I di square. Because sum over I di is 0, it makes no sense. So, the next thing to do is di square. Since it is square, this will be always positive. So, this will be non-zero. So, the first non-zero value you can get, the simplest non-zero value you can get is by squaring and summing. So, let us look at that. So, 75 mark means the deviation is 5, 75 minus 5, 75 minus 70 is 5, and 5 square deviation square is 25. When it is 65, the deviation square is minus 5 square is 25, and 0 deviation square is 0. So, here deviation was minus 5 and plus 5, deviation square is 25 and 25. So, now sum over deviation square, that is 25 plus 25 is 50 plus 0 is 50. 50 divided by 3 is very close to 17, is 16.667. So, the mean square deviation is some positive quantity. So, the mean deviation square, that is this quantity, is known as variance. So, this is very often used in statistics. So, this is called the variance. So, this is another term in statistics. Variance is nothing but sum over I xi minus x average. This is your deviation. You square it. This is your deviation, and deviation square and sum, and this is called variance. Okay. So, what is the variance here? So, here the variance is 16, and the square root of the variance is called standard deviation. So, whatever the square root of 16 point something is 4 point something. So, the square root of 16 is 4 point something. The standard deviation, it is often denoted as sigma, is d square average square root, it is 4. So, standard deviation is a positive number always, because you are finding square and finding the square root of the square. So, this is a positive number. So, in the first case, when in case of your mark where you had roughly similar mark in all of the subjects, your standard deviation was around 4. But now let us take your friend's case. In your friend's case, the marks were extreme, very high mark for biology and very low mark for physics, and a reasonable intermediate mark for the next chemistry subject. So, now let us look at the deviation square. So, the first one is 75 95. So, 95 minus 70 is 25 square. So, it is like 625. So, here it is 35 because 30, 70 minus 40 is 30, 40 minus 70 is 30. So, minus 30 square is 900. So, this is again positive, and 75 and 70 the difference is 5 square, so it is 25. So, the sum is 625 plus 900 plus 25 divided by 3 is 516. 516 is very close to 25, 625 is the square of 25. So, square root of d square average is 22.73. So, the standard deviation is square root of deviation square average. So, such things are called root mean square. So, there is a square, there is a mean, and there is a root. You might have So, standard deviation can be also called as root mean square deviation if you wish. Root mean square deviation, root mean square deviation. So, let me write RMS deviation. That means you find the square of the deviation, average it, and find the square root of it. So, find the square first, average it and find the square. So, root, then mean, square, then mean and then the root. So, this is called root mean square deviation. So, you might have heard in many places root mean square. You might have heard our root mean square velocity. Why do we calculate root mean square first place? Why can't we just square mean? So, as we just saw here, the mean is 0. So, even in the case of gas molecules in this room, you know that some molecules will go this way, some molecules will go that way. So, the velocity has a direction. So, this direction velocity same, some other molecules this direction. So, the average velocity will be 0. Some molecules will be going in this direction, some other molecules will be coming in this direction. So, the average velocity of gas molecules in this room will be 0. So, then since the average is 0, to make some sense out of this velocities, you have to make the deviation from the average. So, then that is essentially like a standard deviation, and that is defined as standard deviation or root mean square deviation. So, that is the way deviation is defined. So, now let us go back to the data and let us look at it. So, if you look at it, the case 1 we had, the average was 70 and the standard deviation was 4. So, we can say that 70 plus or minus 4, because the deviation from the average is 4, the deviation from the mean. In the next case it was 70, then the deviation was 22.73, very close to 23, and this is very close to 4. So, 70 plus or minus 23, and here it is 70 plus or minus 4. So, if you look at here, the extreme values are not very different from 70 plus or minus 4. So, 70 plus 4 minus 4 is 74 plus something, and the extreme value is 75. Here the extreme value is 70, which is 65 minus 4 something. So, these extreme values are not very different from the once you take the plus or minus values. Even here the average is 70, the one extreme value is 95, which is so, and the standard deviation we got was 22.73, which is like 23. So, if you 70 plus 23 is 93, which is very close to this value, and 70 minus 23 is around 67, and 70 minus 23 could be, so what we have is here 70 minus 23. So, this is 47, and 47 is not very far from 40. So, this is another extreme value here. So, basically you have two cases, and two cases average is same 70, but the standard deviations are very different. Here the standard deviation is 20, close to 23, and here the standard deviation is only 4. So, much smaller standard deviation here and much big standard deviation here. So, by just telling the standard deviation also, we are giving much more information that okay, even though the average is 70, the deviation is very large here and the deviation is small here. So, the mark for this case can be very different from 70. The deviation from the average mark is very large and the deviation from the average mark is very small. So, this gives you much more information. So, the moment you see, the moment somebody tells you that the mark is 60 plus or minus 3, then you can immediately guess that the mark is around 60 and the extreme marks somewhere around like 60 is like it can't be very different. It is like around 60 only, like 63 and 57. If you take the extremes are very close to this 63 and some 57. But if somebody tells you my average is 60 plus or minus 30, that means the marks are extreme. Some marks are very low and some marks are very high. So this quantity, the standard deviation. So when this is basically average plus or minus standard deviation. That's what we just discussed. So now before this, so this average plus or minus standard deviation. So now let us once more check the way we calculated standard deviation. So the way we calculated is, we define variance as each mark or each measurement and subtract its average. So you have to first find the average, then subtract the average and find the square and the sum. Very simple. So we have xi minus x average whole square. Now what does this give? So let us check. So what we have is variance, let me call it V for variance, xi minus x average, we know how to calculate x average, and square this and sum over I, and this 1 over n. So what is this? Sum over I, 1 over n, sum over I, x, this is like a minus b whole square. So this is a square minus a square plus b square minus 2ab. So a square is xi square plus b square is x average square minus 2ab is 2xi, a is xi and x average. So this is what it is. So now I can take this inside. So 1 over n into sum over I xi square, the first term, plus 1 over n sum over I x average square. So this is I will go from 1 to n always, I am just not writing it. So n times you have to sum. So I goes from 1 to n, here also I goes from 1 to n, here also I goes from 1 to n, minus sum over I is equal to 1 to n, 1 over n 2 xi x average. So now what is this sum over I 1 to n xi square average this by 1 over n? This term that we mark here. So if you wish, this particular term here, so this particular term here can be written as x square average, because this is x1 square plus x2 square plus x3 square whole thing divided by n. So this is x square average. Now let us take this term. So now let us take this term. This is 1 over n times x square average n times you sum. So when you x square average is a constant like 70, it does not change with respect to I. So if you multiply n into 70, so n, this is like, if you sum some constant 70 n times, you will get n x square average, and you have a divided by n. So you cancel, you essentially get an x square average. So do this carefully by taking some example, and minus, if you do this, x average is a constant, 2 is a constant, so you can take 2 outside, 2 x average outside, and then what you have is sum over I xi 1 over n. So this is nothing but again x average. So what you have is x square average minus x, this is x average square, sorry, x average square minus 2 x average into x average. So, this is again x average square, x average into x average. So, what we have here is that essentially x square average plus x average square minus this, where sum over x is x average is defined in this particular way, which can be written in this particular way, x square average plus x average square minus 2 x average square. So, x average square minus 2 x average square can be written as minus x average square, because this is minus 2 times the same thing. So, basically you get x square average minus x average square. So, this is a very important formula. That the important formula is that variance that is the square mean square of deviation is nothing but x square average minus x average square. Whenever I see this angular bracket, that means average. So, first calculate x square and then calculate the average of it, then subtract from that x average square, and the square root of this variance is called standard deviation or sigma. So, sigma is the standard deviation. This is square root of variance, which is x square average minus x average square. So, this is the definition of standard deviation. So, the standard deviation can be defined as sigma is equal to square root of variance, which is square root of x square average minus x average square. Okay. So, this is, so now you understand how to calculate the standard deviation. In the beginning we said that we said that anything that we say in a sentence can be, some ideas can be written as equations, and can be also shown as some graph. You can plot it. So, we have been always using equations, something, what does it, how do we say it in English, or what do we mean by something? How do we write it in mathematical equation? How do we plot it? How do we show it as a graph? That is we had three parallel ways of representing the same thing. Equation was smaller, just one line will tell you a lot of things. Graph, you need like a big, reasonably good plot, and English you might need many sentences to say that in a plain language. Now, how do we think about this variance, average, etc. in a graphical manner? So, the question, how do we graphically represent this? So, if you were to mark these numbers on a graph, how do you think about average and standard deviation? So, I strongly urge all of you to think things in a graphical, in a pictorial way, so that you get much more idea. So, let us quickly look how do we do this in a pictorial manner. So, let us look here. So, what we have here is, let us take the example of mark itself. So, you have a line representing marks. So, this is 0 and this is, let us say, 100. So, the marks we discussed in the example here, in these two examples, one was 75, 65, 70. So, let us take the case 1 here. So, the 65, so let me mark this 65, and then there is a 70, there is a 70 here. So, let us mark a 70, and then there is 75. So, there is 75. So, now the average, now when we say average, we know that is sum of all this, but when we say standard deviation, what we are doing is, if we mark this x1, x2 and x3 and the average as this particular, here is the average. So, let us mark this as the average, average mark is 70. By doing standard deviation, what we are calculating is this particular distance. So, x3 minus x average square. So, we had to find out x1 minus x average square. So, that is like finding this distance square. x1 minus x average will be like this distance. So, this distance square plus this distance square, this distance. So, that is x1 minus x3 minus x average square plus x average minus x2, x2 minus x average is same, so 0. So, that is 0 anyway. So, this is the kind of, when we think of graphically, essentially we are calculating this distance. So, average distance between this. So, you could always think the standard, and finding the square root of this is essentially like calculating the distance. So, from the average value, how distant are other numbers. So, essentially we are calculating the distance in a graph. So, let us look at the next example a little more carefully here. So, you had this example, look at here, this is 95, 40, 75, this example. So, again let us draw a line. So, we had this is 70 and this is the average mark 70. So, this is the x average. Now, look at here, the next one is 95, which is 95 can be marked here 95, and the other one is 40, this like somewhere here 40. They are very far. So, the distance, and the other one is 75. So, 75 is here pretty close. So, this is, let me call this x1, this is x2 and this is x3. So, when we say x1 minus x average, that is this distance roughly, and this is exactly this distance. So, this is distance. So, then we calculate x2 minus x average, that is this distance. Then we calculate x3 minus x average, that is this distance. So, we calculate that is this distance from here, distance from the average. So, we are calculating the distance from the average in each of these cases and then squaring all this. So, this is distance square and then summing and finding the square root. So, essentially finding the RMS distance, just like we discussed in the case of diffusion. We distance RMS distance, the distance it will diffuse. Here essentially we are calculating some way in RMS distance in the graph. So, when we say standard deviation, we are essentially calculating some kind of how distant the other, when we mark in a graph, if the points are very far away, we know that the standard deviation is very large. So, by just looking at the graph, we can get some idea about standard deviation. So, by looking the two, so in the two cases we had here, the first case we had like 3 marks very close, 65, 70 and 75. In the second case we had marks like this. So, the first these cases were 65, 70 and 75. Here it was 40, 75 and 95. So, these were very far and this is very close to each other. So, just by looking at it, we can figure out that okay, this is very close to each other. So, this is less standard deviation and this is very far. So, this is a bigger standard deviation. So, standard deviation is essentially a measure of how far these points in the graph are. If they are very far, the large standard deviation. So, here the standard deviations was 70 plus or minus 4 something. Here the standard deviation was 70 plus or minus 23 approximately. So, here it is very small standard deviation, big standard deviation, and essentially standard deviation is a measure of how far the points are. So, think of anything graphically. So, with this, let us summarize today's lecture. So, what we discussed so far is two important points. One is average, which is defined as 1 over n sum over xi, you should remember this. And the next one is standard deviation, often denoted by little sigma, which is x square average minus x average square. So, these are the 2 points that you should remember, and you should also remember what they represent. If the points or the marks or experimental data are far away from each other, you will get very large standard deviation, and if they are close to each other, you will get a small standard deviation. So, this much if you understand, you get some basic idea of statistics, but it is very important to understand this very carefully, think about it, do it many examples. So, take many examples from any experiment you have done and calculate average and standard deviation. Calculate the standard deviation of your marks, calculate the standard deviation of heights of your friends, calculate the standard deviation of anything that you can think of that you will be seeing in day to day life, and see what we get and get a clear feeling for this. So, that is the thing that you should do. So, with this simple basic ideas of statistics, we will stop today's lecture, and we will continue discussing statistics in the coming lectures. Bye.